Okay, topic of this video is continuation of binomial probability. Last video we discussed exactly our successes. Now we're going to expand that a little bit. First of all, we'll start with a couple definitions. At least is the amount given or above. So like you must get at least a 65 to pass the Regents exam. All right. So what would be a success there? 65, I guess, right? Or an 80 or a 95 or 100. At most is the amount given or below. In this area, you are legally allowed to drive at most 55 miles per hour. So how fast can you drive and not get a ticket? Like 55, right? 50, 43, anything less than. So at most actually is going to be the number and lower. All right, review. A fair die is tossed 4 times. So what is the probability of tossing a prime number exactly 3 times? That's a binomial probability. So if I'm doing a binomial probability, I'm going to do NRPQ here, where n is the number of trials. I'm tossing the coin 4 times. And I'm answering this first question, prime number exactly 3 times, so r is 3. So if I'm considering that r is 3, that means that I got 3 successes. I'm considering a prime number a success. When you look at a number cube, 1, 2, 3, 4, 5, 6, now the numbers that are prime are 2, 3, and 5, okay? 1 is not a prime number, so I have 3 out of 6. So the probability that it's not prime, 1, 4, or 6, is 3 out of 6 as well. What I'm going to do is going to reduce these because I'm going to raise them to a power. So that's a half and a half. And you can, of course, always use decimals for these, too. You could use 0.5 if you wanted to. Okay, so binomial probability. It's going to be NCR, P to the R, Q to the N minus R. So 4C3, 4 trials, 3 successes. Probability of success here was 1/2, and I wanted 3 successes. The probability of a failure is 1/2, and I only wanted to fail once. Okay, so 4C3 is 4, 1/2 to the third is 1/8, and then 1/2 to the first is 1/2. Now if I multiply here, this is really 4 over 1, I'm going to get 4 over 16. You can reduce that, but I'm going to leave it, and you'll see why soon. All right, exactly 4 times. Well, the only thing that changes is my r becomes 4. Okay, so I could do everything really the same except for where I had the number of successes was 3. I now want it to be 4 successes. And if I have 4 successes, then I'm going to have 0 failures. If I have 4 successes and 4 tries. So 1, 1/16, and 1. All right, so that comes out to 1/16. Because now down here, so what would be the probability of tossing at least 3 prime numbers? All right, well, that's going to be 3 or 4. And in probability, or means add. So the probability of getting 3 prime numbers is 4 out of 16, plus the probability that I could get 4 prime numbers, and it's 1 out of 16. So altogether it's 5 out of 16. And now I think it's probably clear to you why I didn't reduce that 4/16 to 1/4. Okay, the letter is selected at random from the word statistics. In 3 trials, what is the probability in S will be selected at most twice? Okay, so this is a binomial probability. NRPQ. But now, unlike yesterday, I'm not just going to have like a single value for R. All right, I got to take into account all of the possible values. All right, so what is the probability in S will be selected at most twice from 3 trials? So N is 3. All right, and it's at most twice. So at most twice, well, I could have it twice. And remember, it's the number and below. I could also have 1 S selected, and I could also have no S's selected. That would all be success. All right, and what is the probability that I select an S? Well, there's 1, 2, 3 S's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So it's 3 out of 10. Probability of selecting an S. Probability of not selecting an S is 7 out of 10. All right, so here we go. I'm going to take and do, I'm going to do this down here so I have a little more room, because I'm not going to have room to be able to fit it all up there. All right, I need, first, 3C2. Probability that I get an S is 3/10, and I want to get 2 S's, which means probability I don't get is 7/10, and I want that to happen once. Plus, or I could have 3C1, I could have 1 S. 10ths to the first, 7/10 to the second. Or I could have no S's. So probability of S was 3/10, I don't want that to happen. And 7/10, I want that to happen 3 times. All right, and remember, these exponents have to add up to give me n. So 2 plus 1 is 3, 1 plus 2 is 3, 0 plus 3 is 3. All right, 3C2. 3C2 is going to be, 3C2 is 3. 3 tenths squared is 9 1/100ths, and 7 tenths to the first is just 7 tenths. Okay? There we go. 3C1 is 3 is 3C1 is 3 as well. And then that's times 3 tenths. And then that's 7 tenths squared is 49 1/100ths. Right? And then plus 3C0 is 1. 3 tenths to the 0 is 1. And then 7 tenths cubed is, I need to know 7 cubed here. So that's really going to be 49 times 7, which is 343. So I get 343 out of 1,000. Okay, it's time to simplify these terms and combine them if I can. All right. So I need to do 3 times 9 times 7. 3 times 9 times 7. All right, so that's going to be what, 21 times 9? That gives me 189. And all of these denominators should be the same. 100 times 10 is 1,000. All right, now I need 3 times 3 times 49. 3 times 3 is 9. 9 times 49 is 441 over 1,000. And then this last one, really pretty easy because I'm just multiplying by 1 a bunch of times. Okay, I'm just multiplying by 1 a bunch of times. And I'm going to get 343 over 1,000. There we go, and now I just add those numerators. Okay, so I add 343 plus 441 plus 189 gives me a total of 973 out of 1,000. All right, next example. All right, a test has multiple choice questions, each with 5 possible choices. If Sue decides to randomly guess on each question, well, it's probably she will get no more than 3 of the 8 questions correct. All right. Test has multiple choice questions, each with 5 possible choices. If Sue decides to randomly guess on each question, well, probably she get no more than 3 of the 8 questions correct. So, NRPQ, you're either going to get the question right or wrong, so it's a binomial probability. Number of trials, there's 8 questions, right? And I want no more than 3. So no more than 3 is like 3, 2, 1, 0. My P, probability of getting those questions correct, if you're guessing, is 1/5. The probability of getting it wrong is 4/5, okay? Because there's 5 choices. If you pick one, you've got a 1 in 5 chance of guessing the right question, all right? All right, so that's going to be 8C3, 1/5 to the third, 4/5 to the, now what's that going to be? That's going to be to the 5th, because 5 plus 3 adds up to 8, okay? 8C2, 1/5 squared, 4/5 to the 6th, plus 8C1, 1/5 to the first, 4/5 to the 7th, plus 8C0, 1/5 to the 0, 4/5 to the 8th. Okay, and what each one of these terms is representing, this first term here is representing getting 3 of them right. Okay, this one is going to be the probability that you get 2 of them right. There's 1 right, and there's none right. Okay, and I'll leave that to you to kind of like figure out what that would be. All right, just in the interest of time. All right, we'll move on. During the month of May, it was found the probability of rain each day, all right, was 2/5. Okay, at a certain city. What is the probability of rain at least 3 out of 31 days? At least 3 out of 31 days. So if I just start this like a normal binomial probability, NRPQ, all right, what I would have here is it's 31 days, right? And I want at least 3. That's going to be 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 31. So if I do it that way, it's kind of longer, right? What I can do is I can kind of do the opposite of that, right? I can do the opposite of that and figure it out like a shorter way here, right? So actually, how many days do I want it to not rain? Let's think of it that way. Let's think of the success here as not raining, okay? That means I want it to not rain on 2 days, 1 day, or no days, okay? So if I do it that way and think of my success as not raining, it's a lot easier. And then since I'm doing 2, 1, and 0, I'm doing not raining, the success here is no rain. The probability of no rain is 3/5, and the probability of rain is 2/5. So I could do it that way, or I could do it the hard way, all right? And I could consider the success to be rain, which would be 3, 4, 5, all the way up to 31. And I think you'll see, right, that is a much more difficult problem to do, okay, because I don't want to add all those things together, right? All right, so if you think about it that way, instead of figuring it out with the probability it rains, figure out the probability that it doesn't rain on at most 2 days. Because that would give you the same answer. They will be equivalent, okay? So you would do 31C2, 3/5 squared, 2/5 raised to the, and this is where it gets kind of a little bit interesting, 29th, right? Because 2 plus 29 adds up to 31. So if you try and do 2/5 to the 29th power, it's going to give you like a decimal, all right? And if you want it to be a fraction, you can kind of force that by doing each part of it to the power by itself. So 31C1, 3/5 1, 2/5 30, and then 31C0, 3/5 0, 2/5 31. And the interesting part of this is actually finding these fractions raised to those huge powers. All right, let's start with this one. 31C0 is going to be 1. 3/5 to the 0 power is 1. Now 2/5 to the 31 power is going to be huge. All right, let me show you what it would be if you just put that in there. If I did like 2 divide 5, right, and then raise that to the 31 power, it's going to give you a decimal. I mean, you see that, the E negative 13, and that's not really very helpful. If I try math frac, I can turn it into a fraction, and it won't do it. All right? The only way to get a fraction with these huge exponents is to do it like 2 raised to the 31st. All right, there we go. We've got a huge, long number, right? Okay, so I have 2, 1, 4, 7, 4, 8, 3, 6, 4, 8 over, and hopefully it won't give me this in scientific notation, 5 raised to the 31 it's in scientific notation. Okay, now if it gives it to you in scientific notation, then you can of course use decimals, okay? All right, and that's what you will probably be forced to use here, right? This is 4.6566129 times 10 to the 21. Of course, you don't want to really approximate that when you're doing a probability because it's just not going to give you a good answer. So in this example here, really, it's going to be kind of almost impossible to get the answer as a fraction. So if that's the case, if you run into this, then resort to the decimals and put them down in decimal form. Okay? All right. So yeah, I leave to you to try and come up with these values right here in decimal form and scientific notation, right? And then try and add those together and see how you do. All right. Good luck.